So hello everyone, this is our business analytic project and we are presenting average daily screen time hour of Indian kids and these are other attributes of our data set. Now we see the calculation for mean, median and mode. In this data set we have 510 count of the Indian kids for their daily screen time. Here we have calculated the mean. This represents that on an average kids are spending 4.3 hours daily on screen time. Here the median value is same as the mean and here mode we get to know that 11 students have 0 daily screen time. That is 0 is the highest, that is why it is the mode.
After calculating mean, median, mode, we are calculating the quartile of the data. The first quartile indicates 25 percentile of student uses screen time for 3.26 hours or less per day, meaning a quarter of students spend relatively little time on screen. The second quartile, also known as median, shows 50 percentile of student uses screen time for 4.29 hours or less per day, which helps us to understand the typical screen time among the students. The third quartile reveals that 75 percentile of students uses screen time for 5.38 hours or less per day, meaning only top 25 percentile of student uses screen more than this amount. Moreover, the mode tells us that 11 students had no screen time at all, suggesting that some students completely avoid using screen on the days days where the data is collected. Together, these quartile gives us clear picture of how screen time is spread across the different group of students. Thank you.
So after quartile, we are calculating percentile for the average daily screen time. We are calculating 10 percentile, 25th percentile, 58th, 75 and 90th percentile. And for percentile calculation, we are using percentile function. This is our range, and for the 10th percentile, we are giving 0.1 and for the 25th percentile, we are giving 0.25. And this is our interpretation.
So after percentile, we have calculated standard deviation of daily screen time, which is minus 1.792 plus 1.79, and this is the formula. After that, we have calculated variance, and again this is the formula. And then coefficient of variance, we calculated standard deviation of screen time divided by mean of screen time. After calculating SD, variance and CV, we will be seeing the skewness and kurtosis of average daily screen time. This is the value of skewness and this is the value of kurtosis, from which we can interpret that there is no significant difference in the distribution, and we can see that kurtosis is platykurtic.
So here we are calculating the lower bound and upper bound values. Here we have put Q1 and Q3 values, and we are calculating IQR, which is Q3 minus Q1, and for lower bound we are using the formula Q1 minus 1.5 into IQR, and for the upper bound value we are using Q3 plus 1.5 into IQR.
So after calculating lower bound limit and upper bound limit, we calculated association value with the help of Corel function, and we get value minus 0.06, which shows that there is almost no significant relationship between these two variables. In this pivot table, in the column side we have male and female average daily screen time, and on the row side we have the primary devices. So from this pivot table we can interpret in this bar chart that on the x-axis we have the primary devices, and on the y-axis we have the average daily screen time. And from the legend we can say that the blue bar represents the female average daily screen time and the orange bar represents the male average daily screen time. So with the help of another pivot table, we have made area chart, and with the help of this attribute exceed recommend limit on the basis of area, we have taken rural and urban, and in that we have taken two condition, that is false, which means how many people are not crossing the limits, and true, which means how many people are crossing limits. So here we can see that in rural it is false and true. So false, it is less. That means in rural area people are crossing less limit, and in urban people are, as compared to rural, people are crossing limits more in urban area.
So after these two, we are using histogram to show the screen time distribution by age group. So here we can see between 13 to 15, the screen timing is the highest, and from 17 to 19, the screen time is the lowest.
So after integrating all the data, now we are going for this data, and as you can see, x-axis is noting the average screen time daily, and y-axis is the frequency, how many times which screen time is coming more in our data. So as you can see, the 5.3 and the 6.3 is coming more time, 80 to 70t. So this is our distribution curve. It's little bit, we can see is not symmetric, but it's slightly symmetric. So that's our distribution curve of the kids' average screen time.
So now coming to difference in sample mean, which we have calculated from sample mean of urban area minus sample mean of rural area. Then coming to standard error, we have using square root function to calculate it. And then coming to degrees of freedom, which means n1 plus n2 minus 2, which we are getting 27. And then critical value, we have taken 95% of confidence level, and it is 210, so degree of freedom is 27. Then coming to margin of error means critical value into standard of error, which we are getting 0.2387. And then confidence interval, which means sample mean of difference plus or minus margin of error, which we are getting two values, that is minus 0.045 and plus 0.432.
Yeah, so after all of this is our whole data, as you can see. Now we are going for the hypothesis testing, and for hypothesis testing, this is our whole data, and we are dividing this data into two data sets. One is urban and the rural. Can you go for this? Yeah, as you can see in this data set, this is the urban data and this is the rural data, and we are going for hypothesis testing for these two data sets. Yeah, so this is our hypothesis testing, and in hypothesis we have two assumptions. The mean of urban and the mean of rural average daily screen time is equal to, is the null hypothesis, and the alternative hypothesis saying is not equal, the mean of urban and the mean of rural. So from that we are calculating our hypothesis testing. This is our t-test 2 sample hypothesis testing, and we are doing this take table from data analysis. Is the data analysis portion, and we have in the option t-test 2 sample assuming unequal variances, because urban data and rural data does not have a same type of number of sample size. So that's why we are using this test. After that we are going for this table, we are getting this table, and in this table you can see TP2 tail value is 0.83. So our decision rule is saying that if p value less than 0.05, then we are rejecting null hypothesis. If our p value greater than or equal to 0.05, then we fail to reject the null hypothesis. So in this case, we are going for the second decision rule. So as we can see that we can conclude that this means there is no statistically significant difference in the average daily screen time of urban and rural children screen time.